Hi everyone. Now we are going to discuss chemical equation. Chemical equation is the representation of chemical reaction. We already discussed chemical reaction, right? Chemical reaction is a conversion of reactants into product. For example, if you are taking an example, magnesium plus oxygen gives magnesium oxide. It is an example for a chemical reaction. It is very difficult to write word equations. It will take time. Magnesium plus oxygen gives magnesium oxide. It is very difficult to write. Instead of that, we are using symbols. For every element and for every compound, there is a symbol. Using that symbol, we can represent chemical reactions. It is known as chemical equation. We can consider an example here. Mg plus O2 gives MgO. Can you identify the reactants and product in this reaction? Yes, magnesium and oxygen, they are reactants, and MgO, magnesium oxide, is product. It is a representation of chemical reaction. It is a representation of reaction of magnesium with oxygen. It is known as chemical equation. It is a representation of chemical reaction. You all are familiar with law of conservation of mass. What is law of conservation of mass? In every chemical reaction, mass will be always constant. Mass will be remains constant. In every chemical reaction, the mass of reactant will be equal to mass of product, right? That is law of conservation of mass. Here, in reactant side, the number of oxygen is 2. In product side, number of oxygen is only 1. So there will be a change in mass. It is not satisfying law of conservation of mass. This reaction is not satisfying law of conservation of mass. To satisfy law of conservation of mass, we need to balance this equation. Now we are going to discuss how we can balance an equation. Balancing of chemical equation. We are considering an equation. Mg plus O2 gives MgO. Here you can see reactant. This side is reactant side and this side is product side. In reactant you can see 1 magnesium and 2 oxygen. O2 means 2 oxygen. In product side we can see only 1 magnesium and 1 oxygen. It is not balanced because number of oxygens are different in both sides. Here number of oxygen is 2, here number of oxygen is 1. How we can balance it? First we need to consider the number of oxygen. For balancing, the first step is consider number of oxygen or number of hydrogen. Here how many oxygens are there? O2, there are 2 oxygen. Here there are 2 oxygen, and in this side you can see that there is only 1 oxygen, MgO, only 1 oxygen. How we can balance it? First we need to make a box in each term. Magnesium, oxygen, and magnesium oxide. We are making a box here, and inside box we are not able to do anything. We cannot do anything inside the box. We can add numbers on the left side of the box, not inside the box, right? Here first we are going to count number of oxygen in MgO. How many oxygens are there in MgO? There is only 1 oxygen, right? And in this side how many oxygen are there? There are 2 oxygen. Here you can see O2, there are 2 oxygen. How we can balance this equation? In a product side we are going to add a 2. Here we are adding a 2. Now there are 2 oxygen in product side and there are 2 oxygen in reactant side. Now you just observe the number of magnesium. In product side how many magnesiums are there? It is 2 MgO, means there are 2 magnesium. In reactant side there is only 1 magnesium. It is Mg only. So we need to add 2 here also. Here also we are going to add 2. Then it is balanced. So balanced equation is 2Mg plus O2 gives 2 MgO. It is the balanced equation. Now we can go for the next example. Sudden plus O2 gives SUDNO. Here you can see zinc oxide. Here you can see Sudden plus O2. Now first we need to make boxes, right? Here we are making boxes here, and here also we are making box. Sudden also, now it is inside the box. Now we are going to count number of oxygen. In product side how many oxygens are there? There is only 1 oxygen, right? SUDNO, only 1 oxygen. In reactant side how many oxygens are there? There are 2 oxygen. In product side only 1 oxygen. In reactant side there are 2 oxygen. What we can do here? Here we can add a 2. Here we are going to add 2. Now it is 2 ZnO. Now number of oxygens are balanced. Now just go through just observe number of zinc. Here there are 2 ZnO, means there are 2 zinc. Here only Zn only. Here you can see only Zn. Only 1 zinc. So we need to add a 2 here. Now it is the balanced equation. It is a balanced equation. 2 Zn plus O2 gives 2 ZnO. Now we can go for the next example. C plus O2 gives CO. Carbon is combining with oxygen to give carbon monoxide. First we need to make boxes. We are making boxes here. And first we are counting number of oxygen in the product side. How many oxygens are here? CO means only 1 oxygen. And in this side, in the reactant side, how many oxygens are there? It is C plus O2, means there are 2 oxygen. Here 2 oxygen, here 1 oxygen. How we can balance it? Here you can add a 2. Now it is having 2 CO, it is balanced. Here it is 2 oxygen, here also it is 2 oxygen, it is balanced. Now just observe the number of carbon, count the number of carbon. Here how many carbons are there? It is 2 CO. 2 CO means 2 carbon. Here only 1 C, it is 1 carbon. We need to add a 2 here. Now it is balanced equation. 2C plus O2 gives 2CO. That is a balanced equation. Now we can go for the next example. Zn plus H2SO4 gives ZnSO4 plus H2. First we are making boxes. Everywhere you are making boxes. Now just count number of oxygen, and after that count number of hydrogen, then number of zinc, number of sulfur. Here you can see zinc plus H2SO4 gives ZnSO4, zinc sulfate plus H2. Here there are 4 oxygen, right? It is ZnSO4 means SO4, there are 4 oxygen. Here also H2SO4, 4 oxygen. Number of oxygens are balanced. Now we can go for number of hydrogen. Here how many hydrogens are there? It is H2, right? There are 2 hydrogen. H2 means 2 hydrogen. Here how many hydrogens are there? In the reactant side you can see H2SO4 means H2, 2 hydrogen. It is also same. Number of hydrogen and number of oxygens are same. Now we can go for number of zinc. In this side how many zinc you can see? ZnSO4, right? ZnSO4 means there is only 1 zinc. In this side only 1 zinc, in product side only 1 zinc, in reactant side there is only 1 zinc. It is also balanced. And now sulfur, in reactants, in product side how many sulfur you can see? ZnSO4 only 1 sulfur, right? Here only 1 sulfur, and here H2SO4 only 1 sulfur. It is balanced equation. This equation is balanced, no need to do anything. Zn plus H2SO4 gives ZnSO4 plus H2. It is a balanced equation. It is balanced. Now we can go for the next example. Fe plus H2O gives Fe3O4 plus H2. It is the equation. First step is making boxes. We are making boxes here. Here also we are making boxes, and here also we are making boxes. Now we are going to count number of oxygen. How many oxygens are there in the product side? It is Fe3O4. There are 4 oxygen, right? Here you can see there are 4 oxygen. In the reactant side it is H2O. H2O means only 1 oxygen. So we need to add a 4. In the side of H2O we need to add a 4. We cannot do anything inside the bracket. So we are adding a 4 here. We added a 4 here. Now it is 4 H2O. 4 H2O means there are 4 oxygen. Then number of hydrogen. If we are adding 4, there will be change in number of hydrogen, right? It is 4 H2O means 4 into H2. 4 into H2 means 8 hydrogen. Here there is only 2 hydrogen. So we need to add a 4 here also. Here also we are adding 4. 4 into 2, 8 hydrogen. Here also 4 into 2, 8 hydrogen. Now we can check the number of iron, Fe. How many Fe you can see here? It is Fe3O4, 3 Fe. And in the reactant side, how many Fe you can see? Only 1 Fe. We need to add a 3 here. Now it is balanced. The reaction is 3 Fe plus 4 H2O gives Fe3O4 plus 4 H2. That is a reaction. Now it is a balanced equation. 3 Fe plus 4 H2O gives Fe3O4 plus 4 H2. Now it is a chemical equation, right? Chemical equation means it should give full information about the reactant and product. We can add physical state of the reactant and you can add physical state of product. Here, what is the physical state of Fe? Fe is a solid, iron is a solid, right? So we can add S here. And what is the physical state of H2O? H2O is liquid, so we can add L here, it is liquid. And in the case of Fe3O4, Fe3O4 is a solid, we can add solid S here. And the hydrogen is a gas, we can add gas G here. It is giving complete information about the physical state of the reactant and product. Now it is a chemical equation. If you want, we can add temperature of the reaction above the arrow. Here you can see the arrow. Above the arrow you can write pressure and temperature. Subscribe our channel for getting instant notification of sample paper solution and support us for providing free online classes to everyone. www.winpointonlineclasses.com